Good morning and welcome to the fourth of a series that we're covering the NCETM's 5 Big Ideas. My name is Tom Manners. On Twitter, I'm at Manomatics. I'm joined today by Hyper Helga, hyper being the absolute key word because Helen is ridiculously enthusiastic and passionate. I am sure that it's going to be a really informative hour, and it's occurred to me that for the last 20 seconds I thought I was sharing my screen, but I wasn't. I don't know, I'm looking forward to today. Helen, hello.
Good morning. Good morning. Looking forward to it.
It's going to be great. I don't know what it is. There's something in the back of my head because coherence is probably the one that I've often found the most challenging. And before we just started recording now as well, we've been saying that when we try and model this in schools, it's often the one that people get a little bit more bit worried about. So I think it's in the back of my head that I'm just a little bit worried about. But that's the good part of it, because I would say if I recorded this in a year, I'd be better. Record it in 2 years, I'd be better than that. Part of being involved with the hubs and the NCETM is to continually progress, not just get it straight away. I mean, you said earlier on, for example, again, before we start recording, that you didn't see some of the coherence steps from some textbooks when you started with them, but now you do.
Absolutely, yeah. I think you need to keep returning and keep looking at things, and I think you keep changing your idea of what you know and how much you understand. So don't look at it first off and think, yeah, I know everything, I'm fine. It's just that thing about CPD, isn't it? It keeps on going.
It's continuous, or whatever the word is supposed to be that we use. Let's have a look at what I prepared to remind us, because this was the screen that was supposed to be sharing just a moment ago. Small steps are easier to take. Now, of course, if you are watching this and you know nothing about the Maths Hubs, I've mentioned it every time. Please find out where your local Maths Hub is. Find out the events that are going on, how you can be getting involved. I know that local hubs are advertising for new mastery specialists if you wanted to go down that route, or if you wanted to be a mastery advocate where specialists like myself and Helen come to your school. You might just get in for some areas. It's around this time we're worrying about it. I know secondary, in fact, Helen, do you happen to know? I know secondary, the deadline has been moved to next term, so there's a bit more time. Is that the same for primary?
No, primary, the deadline has really finished. I think most hubs have either interviewed or about to interview. Yeah. There may be the odd few hubs that they've still got a window, but I'd look soon now, because I think primary, the deadline has either just passed or it's around about now. But for schools recruiting, I know they're recruiting for research schools and for readiness schools. There's lots of recruitment for schools for CPD.
And there's also work groups that go on through the year as well. So
absolutely,
it's not shut down. If you wanted to be part of the whole teaching mastery program, that could be even next year. But getting involved with the work groups, I really enjoy what I've learned from being part of the Maths Hubs. So then, thank you for tuning in. Again, who am I? And I'm PGC Tutor for Maths at Arthur Terry. I'm meeting my trainees straight after this, looking forward to it for next year. I'm a teaching for mastery specialist and a PD lead and work group lead. Helen is all of this. She has so many more titles than me. And by the end of the hour, you'll see why. She knows a lot. She's been brilliant to work with on this series. But again, we both teaching for mastery leads between primary and secondary, and I'm hoping that by doing this series, I've been trying to make that link between primary and secondary, that we all are teaching the same maths, and the more we can be coherent in our journey through the pupils, that they have a similar experience from primary to secondary. I think that's really important. That's why I really love working with Helen and Faye on this series. Now, mastery in maths might mean different things to different people. But I don't always refer to these, but we're using research, and I'm going to talk about some of the research in a few minutes' time. But the essential idea there is a deep understanding of the maths that they're learning. And when people argue about what is mastery, I do the inverted commas virtually every time. But the reason I found this slide, one that I found from one session with the NCETM, and notice the word connected. And I noticed it twice when preparing for tonight. But to know that's really important, because coherence is about connections, making connections from what they already know, but also for the journey we're hoping to go forward. So let's get started. These are the 5 big ideas. We're looking at the one that people often say there's only 4 there. They don't realize the diagram on the left-hand side. But connections, it says it in the writing, if you like, in all 4 corners, making connections. Coherence is really about making connections, and it runs through. That's the way I've always seen it, Helen, the idea that the coherence is running through all 4. That's the point, isn't it?
Absolutely. I think of it a bit like sort of the glue that holds it all together. It's so important, But because some people don't actually initially see it when they look at that image, sometimes it can be forgotten. But I think it's the most important thing on there.
Well, we're going to do our best to cover it in this hour. So producer Adam will be looking at anything that comes in on Twitter, and people just tend to sit back and chat now. But producer Adam, can you come and help?
Yeah, I can.
Yeah. Can you read this for me, please?
Absolutely not. I'm not even going to try to attempt to read because it's become quite offensive potentially.
Why can't you read it though?
Because it's not using a language or alphabet structure which I know anything about.
So in other words, it's completely out of your knowledge base. You have nothing to connect from there to there. Okay. Now I'm going to use something I think called Pinyin, which is the Chinese. Helen, I'm kind of wondering, by the way, if you could answer this, because I know you've been in Shanghai. Have you learned any Chinese? Do you think you know what that says?
No.
Okay, good. Let's find out then. Now, Pinyin uses the English alphabet to try and pronounce Chinese words. So there we go. Now, could you have a go, Adam?
Okay. Wo bu zidao.
Now, the thing is, I don't know if you're actually accurate there at all. But the point is, you were now willing to have a go.
Yeah.
Now, what you did there was model what we get with pupils. If it's completely foreign to them, no pun intended, they won't go for it. It's outside their comfort zone. We talk about the zone of proximal development from Vygotsky, which we'll get to in a minute. But you were able to have a go at that. But actually, you may have said the right answer because that actually means I don't know. But because we've now changed it into something that a pupil can access, and this instance, the pupil, head of maths in his school, can access, then it became a little bit nearer. And that's the thing about coherence. It was a smaller step. It was too big a step for you to go to the Chinese language, but actually using something that you're aware of, it gave you just that little bit closer to it. And when a new concept is encountered, in order for learning to take place, one of two things must happen. Either the new idea is connected to and incorporated into the learner's existing framework of knowledge. And the framework of knowledge for Adam there was the English language, the English alphabet. He wasn't able to go straight to the Chinese alphabet. Or existing knowledge structures must be extended or reorganized. And maybe the extensions would be some of the accents that were put on some of the English alphabet there. But some of this assimilation and accommodation is something we'll consider when we look at coherence in a few moments. And what I will make sure is that all the references that are we look at over the course of this hour are put on YouTube at the end as well, below the video. So for teaching to result in meaningful knowledge, we need to know students' prior knowledge. Now, I didn't check before. Adam apparently did not know the Chinese alphabet. I didn't know that. Vygotsky, here it is. The zone of proximal development is helpful here. It's the distance between where a student is on their own and where they can get to with the help of a more knowledgeable other. Learning things that are just beyond where their current understanding is. And in that example there, it was just beyond, and he had a go. And if we can do something that the pupils feel it's within their reach, if it's too far out the reach, it just stops. And we get that maths anxiety that we've spoken about frequently. Maths is a connected body of language. And with this in mind, coherence in maths education involves taking on learning in small steps. It's from Hodgen and William, whilst making connections with the previous learning. And again, linking back to Skemp's work and how relational understanding and how ideas interrelate. Skemp's work being very important. Helen, certainly when I first came across Maths No Problem, Yip Van Haar was talking about Skemp a lot, and relational understanding, procedural fluency. Those two really have to go hand in hand, don't they?
Absolutely, yeah. And I think one of the good things about using some of the textbooks that are available at the moment is that they help you to return. I think we looked at all these theories, didn't we? And we did all this reading when we did our degrees to be teachers. And then sometimes you forget the research and the theories. And I think to look at the textbooks, the good quality ones, they are actually based on these ideas. So they help you to understand them and return to those ideas and look at them again.
And you've got to remember there's only 2 textbooks that the DFE actually approve. And we are at a nice stage though that the DFE, Ofsted, Maths Research, I've said this virtually every week now, we're all aligned at the moment. But I find that really interesting. Everyone believes the same things about maths education, but I find it really interesting that there are only 2 books that the DFE are willing to promote, both in primary.
Absolutely, yeah.
So we'll look at some of those in just a few moments, I'm sure. So we saw the 5 big ideas earlier on, and those words making connections are spread across them all. It's found that the successful maths teachers demonstrate connections between different yet related areas of maths and encourage the use of different methods. And we talked about that in the fluency with Faye last week, but making those connections. So it's, and then we'll talk a little bit maybe about how the brain works and the schema and the long-term memory and short-term memory, because I think coherence really links to cognitive load theory in that respect. So now I'm going to refer to that in this hour. But there is making connections throughout it. But as Helen said, coherence is the glue that keeps it all together. And we're now beginning to see how important it is that those connections are small, but also making sure we're trying to, for the whole map of mathematics, make those connections. That looks like it's the same slide I saw before, but there it is. That's in the national curriculum. It's a reminder maths is an interconnected subject, and we want pupils to move fluently between those representations, different representations of ideas. Rosenshine, very important book. It's a very popular book at the moment, but Rosenshine, of course, the original paper, 2012. Our working memory, the place where we process information, is small. It can only handle a few bits of information at once. And so atomization is what a lot of people are talking about. Breaking it down into those small steps is the word that people are using, atomization, because too much information swamps our working memory. Presenting too much material at once may confuse students because their working memory will be unable to process it. Now, Helen, this is where I know the work of Rosenshine we use a lot in the skit that I work in, and across our teacher training, but also across the multi-academy trust I work with. Is it something that the Rosenshine's principles is just as valued in primary?
Absolutely. I think more so over the last couple of years. A lot of the work we've been doing with primary is looking more into this, because I do think that this has been perhaps a danger when the curriculum changed, and I'm almost scared that when autumn comes, it might almost be a little bit of a danger again, that people have the idea of where the children need to get to, and they're in such a rush to get there, they rush through too much too quickly, and they make jumps that are too big. So big work that we've been doing with Teaching for Mastery, working with primary schools, is saying slow it down, break it up, spend longer on things. But sometimes that can be quite hard for people to get their head around and think, well, how's it all going to fit in? And they're just focused on the end point. And that's where some children drop off and fall out. And it's not that they can't, it's that actually they have been scared off or have been lost along the way in the jumps.
Just want to share a bit more of the research, if I may. I'm just pressing the wrong buttons there. Hopefully you can now see what I'm doing. I really like this image. It was in Craig Barton's book, 2018. He talked about transferring from working memory to long-term memory. It was one of the first times I really began to kind of understand what was going on. The circles representing units of knowledge, and the knowledge then going to the ovals, the schemas, the line, and we make those connections. And if they've made those connections, it's stored stronger in the long-term memory, but we've got to transfer it to the working memory. Now, if it's not something you've thought about in a long time, it's harder to grab it from your long-term memory. And some lovely citations, quotations from the book. Bjork, 1975, retrieval is a powerful memory modifier. In other words, if you've thought about it recently, it's more likely to be able to come back. There's long-term memory, there's almost long-term memory. Understanding is remembering in disguise. Because that's, again, talking about those connections that you've got to make, that if you understand something new, well, in fact, you are remembering it, as we said about those, the assimilation earlier on, about remembering the previous knowledge that you've got and making those connections to it. And of course, if you want it to actually stick, learning happens when people have to think hard, as Co says. And that's a reminder that it's not just that fluency of just doing something and I'm going to say procedure as opposed to fluency, because we talked about fluency last week. Fluency isn't just the accuracy of doing something. It's having to really think about it and apply your thoughts and be able to reason from it. And so I just thought that was a really, it's a nice chapter, that, from his book, as a matter of fact. Now, I want to go back to Rosenshine. Very wordy, this, I apologize. But I think it's just a reminder for people to go and look at this in their own time. But I know, like, looking at this paragraph straight away, it mentioned that the most effective maths teacher spent about 23 minutes of a 40-minute period in lecture, demonstration, questioning. The least effective teacher spent only 11 minutes presenting new material. And that links to what you were saying, Helen, about making sure we don't rush through it, because we're obviously, with the world being as it has been, we might just go to what we think are tricks. We might just go to the quick way of getting somewhere, but that's still, we know from research, that's not going to help.
No, absolutely. I think that's more likely to frighten children off and make them feel really anxious. And it's definitely not going to lead to mastery of mathematics, understanding mathematics at all. So it's all going to fall down somewhere. So it's something really important to think about. Yeah.
And it has implications for curriculum design, doesn't it? The curriculum design and the lesson design. And I think we'll talk about that today, looking at something what people call the S plan, even though it looks nothing like an S. That's where people get cross at it. So the NCETM share these 5 big ideas, and they've broken each of them down. The key messages for coherence, which we'll cover quickly now and cover at the end again. Those small steps are easier to take. They're easier to take for the pupils. They're easier to take for us to break down and for our learning as well. And it's important we break them down in the right order. Now, focusing on one key point each lesson allows for that deep and sustainable learning, i.e., not just being able to perform that key point, but understand it and apply it. Think about your AO1, AO2, AO3, fluency, reasoning, and problem solving. So if we have broken it down to those key points, it makes it a lot easier for us to challenge them deeper. And we said, as the quote earlier on, and I use Willingham all the time, memory is the residue of thought. If they've thought about it, it's more likely to stick. Certain images, techniques, and concepts are important precursors to later ideas. So if I was trying to teach Adam Chinese, the building blocks used Pinyin. It was the Chinese using the English alphabet. So those concepts are important. Now, getting the sequencing of these is right. And that's something we'll talk about with the S plan as well, that we get the order of these ideas correct. If we get those wrong, then the sequence is off, and maybe those building blocks, maths is a foundational subject, a building block subject after all. We've got to get those right. When introducing new ideas, with the research has shown this as well, it's important to make connections with earlier ones that have already been understood. And when something has been deeply understood and mastered, it can and then should be used in the next steps of learning. I'm hoping some of that research is a reminder to everybody that, well, we're a research-led profession, and that's growing. I would say when I started, I don't think it was considered as important. As you said, I think something similar earlier, Helen, that we're beginning to pay more attention to the research, because the negative towards research sometimes is, oh, I know my class. But it's not about take research and use it. It's about take research and consider how can I use it best. And that's a really big difference, isn't it? And I think what you said is really important, actually. We can't forget all this when we return to a normality.
Yeah, I think absolutely. I think when you think about what the slide that you've just shown about starting from what pupils know and those small steps, I think that's what we need to think about in September as well, isn't it? Start from where they were secure the previous year. Start from what they were familiar with. Start with the language and the representations they were familiar with, and build from there. Because if you just throw children in at the new year, the next year's curriculum, and start running with your maths lessons in September, that's going to be really, really scary. But then again, you can't spend a whole term re-going through everything that they've missed out this summer term. So I think looking to research and looking to work with that in the autumn term will be really, really useful. Getting that coherent journey going through, that then each step, it's what connects those steps, isn't it? It connects them, and then what else that connects to. So that those ideas, the small steps, but the connected learning, really, really important.
And the importance of a good scheme of work to make sure that supports teachers, because both in primary and secondary are people who teach maths who aren't completely confident. And we have a number of non-specialists, and then you have people who are just new to the profession as well. And so the importance of a good scheme of work, breaking down that into those small steps or key learning points, I often see them addressed as, is really important. And so for people watching this who are heads of departments or who lead maths in a school, breaking that down to support your staff is really important. Helen, I know we, again, before we started, we talked about some of the schemes of work that you engage with and you work with. I know we're going to talk through some of that. I wanted to mention some of the S plans. Where would you want to start then? Where we've looked through the research, where is it that you think the most important things we need to look at?
I think if I go and share a couple of my slides with you, I'm just going to go and share my screen. I'm going to start thinking about the oh, sorry, I didn't mean to start at the beginning.
You've got the double slide so we can see your next one again.
Right, yeah.
Oh, we'll get it right.
I'm going to start.
See, we always meet quarter of an hour beforehand, and it worked then, of course.
It works then. Look.
Hooray, there we go, thank you.
I always think that teaching for mastery, that coherence is that glue that holds everything else together. So it's so important, like I said. It's kind of like the map. You know where you are right now, and you know where you need to get to, and you need to work out that route. Now, I shouldn't really admit this, supposed to be a mathematician, but I'm geographically challenged. I find it really, really hard to read maps and to remember routes. So I rely a lot on a sat-nav. But I think the danger of that, I relate the sat-nav maybe to the textbooks and things like that. We all know that sometimes a sat-nav can take you down somewhere where you don't want to be, or they're not perfect. Yeah. So I think you still need to use your brain and still need to think. So even when you're using a textbook or following some guidance or a scheme, you've still got to use your teacher knowledge and your understanding of your children and your formative assessment. Don't just blindly follow something. You've still got to engage in it. I quite like this thinking around, because I think coherence sometimes people can struggle with. And I quite like that little excerpt from Mark McCourt's book there. But when you're thinking about how things build, and you looking at the very end there where it says about mathematics, the graceful dance that is mathematics. And I think so many people are scared of maths or dislike maths or anxious about maths. And I think that's because when they were taught, they didn't have this coherent journey. They got lost somewhere along the way. And I think that's really, really sad. So just thinking about getting that sequencing right for all of our learners, and that's for our new teachers and our current teachers, as well as for our children, it's really, really important. So looking at it across, the long term, across the medium term, and then also through a lesson. So you've got your coherent journey through a year, through a sequence of lessons, through a unit, and then through an individual lesson as well. And that individual lesson planning is really, really important. And I think the other key important thing is that prior knowledge. How do you know what the prior knowledge is? So the textbooks, again, can really, really help you with that. Just to flag up really that, this again links to the guidance that comes out from EEF for primary schools and early years settings. Now, if you're looking at prior knowledge and you're looking at sequencing and you're looking at the baby steps, the one thing that can be really, really hard is subject knowledge. If you haven't got the subject knowledge, or you haven't got the experience, you haven't been teaching, that you don't know what the tricky bits are, what the misconceptions could be. Oh, I'm teaching in year 5, but what happens if, when they encountered this subject before, they developed a misconception? How do I tackle that? So that's one of the things that the math subs have been working on, developing subject knowledge, really, really important for teachers.
Helen, can I at that stage just mention about misconceptions, and don't run that slide? How will you identify prior knowledge slide? Could you reopen that? Because there's something I want to point out from that one, slide 8. That's the one. If you just reopen that for me a second. Regarding misconceptions, I interviewed Craig Barton on Wednesday. Fascinating how strong the data is on his website now. So you can look at see how people's have how they've got it wrong, and they explain why in their own words. Really good for teacher training. And of course, there's a lot of Key Stage 2 content on there. And the website's growing and growing. It wouldn't surprise me if it started going down to Key Stage 1 soon as well. But the pupils explain why they misunderstand, and you can see the percentages, how much get it right and why. So you said about teachers being a little bit nervous about knowing the misconceptions. Really, really powerful website to use, free to use as well for everybody. I wanted to point out one thing there, the last thing in brackets. Learning a key point does not always fit into 1 hour chunks of time. Now, I think one of the better schemes of work in secondary, this is for breaking down key learning points, is the kangaroo maths. White Row Maths is doing something very similar now, where they're trying to do key learning points. I think you can continually atomize those even further, but on kangaroo maths, it has, say, 7 key learning points, and it says 7 hours. But it does come with a key warning, which is exactly what you've written there. one key point does not always fit into 1 hour. And to think that it's ludicrous, because how do we know how long it's going to take for people to learn one concept? And we want to make sure they've got it before we move on to that next connected point. So I'm assuming you have that same concern with primary teachers as well, Helen, and that's,
and I think
that lesson. Well, do you know what? That's because it was a tougher concept.
Yeah. And I think that's important when you're using any kind of scheme or any kind of textbook, because the textbook doesn't know your children. It doesn't know the journey that they've been on to get to the current point. And you might need longer on a key point for your children. It doesn't mean that you've got to plough through a textbook. You know, today I'm doing this, the next day I'm doing that. Some lessons you might need longer on. And I think that is really, really important to think about that. I think that's something maybe going back to the old curriculum and the old sort of Ofsted, where people thought every day had to be a different learning objective and they had to make progress and have understood all of that in one lesson.
Yeah.
Sort of thinking around that's moved on a little bit since then.
And there's training for us as maths, I don't want to use the word experts, but to be encouraging leadership to understand that as well, and to accept that, because we can't accept that learning a key point will always fit in 1 hour. It doesn't work like that. I'm quite passionate about that, actually. But yeah, sorry, thank you. I just wanted to go back to that, so thank you for that. That's brilliant.
Yeah, no. What I would like to do is to point out to some resources and just really where it's kind of fitted in with my thinking. Something that I think is important is that every school has their own long-term plan. That regardless of whether you're using a textbook or whatever you're using, you've got a long-term plan that works for your school, your curriculum, your children, based on where they're at, where they were at previously, based on your school year. And I do find a lot of schools kind of just pick up something off the shelf and then don't have something that works for their children. So I do think that's something important. Whatever scheme or whatever other resources you're using, think about your school and your children and keep thinking about it. So one of the things that I find is not just end of year data, but the ongoing same day intervention data tells me a lot of information as to whether children need longer on certain topics or whether topics need looking at.
I don't want anyone who's secondary to be watching this thinking that they don't do that, because there's beginning to be research in secondary schools who do look at same day intervention. There were schools in Shanghai who did that, and so they were researching as to how the power, I think Emma McRae's following this, as to how secondaries can try and intervene a little bit quicker, because it is a different setup and we have to accept that. But I think there's progress in that, so I'm looking forward to reading that when it does come out. But yeah, you're absolutely right that there are so many different ways of making sure that we respond quicker, and also so many different ways that we can consider the curriculum to make sure that we're just thinking that little bit longer. I know I cited Mike McCourt once by saying that we don't just teach to that year, you teach forward maths. So it's not just passing as you suggested earlier, Helen. It was get it right in this lesson, I've done my job. Well, actually, no, if you've not done it as part of the journey, because the journey is going to continue after your lesson. It's going to continue to another year group. And if you haven't helped that journey, you've hindered it, quite simply.
Helen, just a quick question. How do you do that in primary schools now? Because obviously in secondary schools, we sometimes have groups which will follow us from year 7 to year 11, say. In primary schools, often they, correct me if I'm wrong, they change between teachers, between year groups. So how do you kind of promote that coherence so that the year 1 teacher and the year 2 teacher and the year 3 teacher is seeing that mathematical journey over the course of that primary education? Because I imagine it's a little bit more tricky than maybe in secondary school.
It is. I mean, a lot of that is down to the CPD that takes place, because we believe it's important all primary teachers have that horizon knowledge. Yeah. So just because you tend to only teach in Key Stage 2, it doesn't mean you shouldn't know about early years maths. Just because you tend to only be in early years, it doesn't mean you shouldn't know about year 6. So it's really important, and again, you know, that we know about year 7 and year 8 where the children are going to. So bringing teachers together, when we do subject knowledge enhancement, we look at the whole of the curriculum and just beyond year 6, so that we know where they're going to. Because at any point you need to be able to track back. You need to know that whole journey. And I think that's what's really important. That's something that I learned in my work since being in Shanghai, actually, a few years ago, that actually it was where it was all starting that we needed to do the most work. In my school, we started looking at year one, and I quickly realised, hang on a minute, we've got to go back to early years. If we can get it right in early years, if we can introduce all of these things the right way at the beginning, we're not going to hit all these problems later on. So I think having that long-term plan and having a textbook or something like that's really important. But you need to bring your staff together on a regular basis to get them all to understand not just their own year group. And I think getting feedback from teachers and things like that. So from the same day intervention, that's really useful for me, because I can look at that. And if children are really struggling in year 3 with multiplication, and lots of them are needing same day intervention, I can go back and look at year 2 and year 1 and think, what wasn't in place in the sequence before then that made all of these children need an intervention in year 3 in this topic? What didn't we get right about the sequencing or the timing of it? We need to relook at that. It's not just about, oh, we need lots of interventions for these children. It's why do they need the intervention? What's gone wrong before? That's what's useful.
So with that, the importance of prerequisites in the prerequisite knowledge in your scheme of work, again, supporting your staff, it's really important. So those skills that you pointed out when I think I showed the slide earlier on, what's the prior knowledge? So having that horizon journey. Now you mentioned, of course, that the NCETM webpage has those quite nicely set out for a lot of subjects, doesn't it?
It does, indeed, it does. I think if I just give you an example of a question here.
I took your screen, so if you want to share your screen again, by the way. Adam, does it answer your question, by the way?
Yeah, it really does. And it's just an interesting thought, like whether in primary schools, and this is going to be probably very ignorant of me, but in primary schools, whether you have primary teachers who do follow students up from like reception to year 6, whether that would ever be a thing which could happen at all.
I think one thing that some primaries, I mean, sometimes you get the same teacher for 2 years running.
Yeah.
And I think a lot of schools are possibly doing that next year. They're trying to keep.
Yeah. That makes sense.
And some schools have got specialist teachers teaching maths, but not many in primary, not many at all.
I've always wondered why not. I've always thought that's something it just seems such a shame. I understand that the younger maybe that they want the person they're most comfortable with most often, but I've often wondered why we don't have more primary specialists in each school. But I suppose that's probably just logistics, I would imagine.
I don't know. I think if you're teaching children all day, all the subjects, it gives you far more opportunity to make the connections across the whole curriculum. Because you've taught them the maths, and you're going to be teaching them the science, and you're going to be teaching them the PE, and you're going to be teaching them the art and the DT. It makes it much easier to connect all of those.
Yeah.
I love hearing new ideas like that. It's great.
If I just show you that very simple question there, and I ask about how a young child might solve that, when I think with teachers about this, I mean, how would you say a very young child would solve that problem?
Counting up.
They could count up. Before even counting up, very young children would do what?
My son's not old enough yet, and I haven't had that experience with Key Stage 1 as often. So, before counting upwards?
Before counting up, they'd count all. They'd have 4 things and 13 things, and they'd count all of them from the beginning, wouldn't they?
Okay.
Then counting on, where would you think children would start counting on from when they look at that problem?
Oh, they'll count from 4.
Yeah, because that comes first, and they learn to read from. But at some point, they move on to starting at the greater number. Now, in the past, very often that was because we told them, and it was a rule, and they had to remember it. You always start counting on from the biggest number. Hopefully, it's a little bit more of them understanding why now. Then they get to a point where they use their known facts. So in year 2, children would learn that 4 and 13, that they'd understand what, they'd just remember that as a fact. But then there's that thing called derived facts. And actually, if you want a child to be able to answer a question like that when they're in year 2, you need to ensure that before then, they know about 4 and 3. because if they know about 4 and 3, they can apply that to 4 and 13. And I think that's the key thing. I've looked at this with some research that Joe Bowler did, that children get stuck. And that if we've got children moving into Key Stage 2 that are still relying on counting all and counting on, when they get to Key Stage 2 and the numbers get bigger and the maths gets harder, they are the children that are still going to be counting on and counting all the way through Key Stage 2, but they're going to start to fail. They're going to find it really hard work. And it's not because they can't, but it's because those basics weren't in place. They weren't memorizing their known facts and then using those known facts, applying them, so using those derived facts. So I think if we can get the teaching the known facts right from the beginning, if we can use, teaching for mastery approaches, so that when children encounter something like that when they're in Key Stage 2, they're not going to use a written method. They're not going to use a number line. They're not going to put the biggest number in their head and count on. They're actually going to look at that and think, well, actually, 100 is jumping out at me because I've got 9 10s and 1 10, and I know, it's going to be 100. And I know about 6 and 7. I know that instantly. It's a known fact. So spending long enough on you'll have talked about fluency last week, I know. But if you haven't got that right in your sequencing through the school, if you've got children going into Key Stage 2 that don't know these facts and can't apply them, that's going to hold them up in Key Stage 2.
Your example 2 slides before, and if I may, one more again, if I may, one more slide back. There it is. The fact you went to representation, so it said 4 plus 13, and this is just a reminder for people who aren't sold on representation if they haven't been. Why wouldn't you? Yes, you said about seeing the left number, then add the right number, if you like, or the first number, then add the second number. But actually here, immediately, because there's a picture, I want to put the 4 with the 3. And suddenly representation gives me a conversation saying, well, does it matter which one I'm really dealing with first? 4 plus 13. And then you can talk about the order of addition doesn't matter. But that's the point of where representation breaks that down and enables that conversation more, because I immediately didn't worry about 4 and counting on, if you like. I just saw them go together, and then you can change the representation as well. So I just wanted to go back to that, because I think that has real power.
I think it's building those key representations from the very beginning. All children can subitize. They can subitize, building the subitizing up, and then helping them to be fluent with those key facts. Getting it right from the beginning. So again, the NCETM have got some really great resources for early years that really help with this sequencing. I think early years sometimes were missed out a little bit before, but seeing the order in which those things can come in, being able to unpick them. Another book that I found really useful when it comes to getting the sequencing right. I don't know if have you looked at Learning Trajectories?
No.
That's quite an interesting read, looking at getting that sequencing right, a bit like with the numbers count interventions and things like that. It's all those baby steps that you have to consider, because if one of those isn't right, a child's going to be struggling. Another great resource for getting the sequencing right for early years and onwards is that one there, Ericsson Institute. I don't know if you've come across that at all, but that's good ideas in there. When I first went to Shanghai and I looked at the Shanghai textbooks and I saw how the very young children encountered 3D shapes before 2D shapes and how they did it, it didn't make any sense to me. And when I came back to this country and we started using a textbook based on Singapore, they did the same thing. And I looked at that and I thought, yeah, but we don't do that here. We teach 2D shapes first. So actually, I'm going to change the textbook and we'll follow those lessons, but actually we'll do the 2D first and then the 3D, because that's how we've always done it here. And I asked why, and my colleagues in Shanghai said, well, when you've got very, very young children, where in real life, where in their play do they encounter 2-dimensional shapes? And it was like, and the fact that they explained, well, actually, because they pick up objects in their environment when they first come to school, they're picking them up, they're exploring. Does it roll? Can I roll it along the floor? Can I throw it? Does it do this? starting from that natural exploration, that's why they do 3D shape first. That's why it's so important. And they don't start by holding up a shape and saying, this is called a cube, these are the properties, remember it. They start from, oh, what can you do with that? How does it move? Oh, it rolls, or it doesn't roll. Oh, great, we can sort them. They roll or they don't roll. And I think that sequencing from a very simple beginning, pitching up with a real depth of understanding rather than going in with, well, this is what they need to know, so I'm going to tell them and I want them to remember. I think that's really, really important, and that's where the textbooks, as I say, can come in really, really handy. Again, if you want children to be fluent with their number facts and with arithmetic, you want them to be, you know, proficient at arithmetic, you don't just start by giving them loads of arithmetic. You start with, well, what do I introduce first? How do I introduce that? What images am I going to use? What representations? What language? How does that connect? And that's where, as I say, the NCETM materials can really help you with getting that sequencing right, breaking it down. What do I teach when? I think the subtraction in Key Stage 1 used to start with reduction. I've got so many sweets and some of them have been taken away, but the NCETM teach you how to teach it through partitioning and really getting that sequencing right and how to connect them is something really, really useful.
I'm trying to find the resources because I want to make sure we do show them that on the NCETM website, again, it's free to sign up, that it breaks down those. So I don't know if you've got some of them showing, but that shows it for year one. These exist, and the mastery to professional development thing is showing there.
Yeah.
It breaks down the learning as well. And I know you're worried about people jumping in and jumping out. That's the point of trying to stick with the journeys that they help with you with to break down all the learning points. Can I steal the screen just a moment, if I may?
Yeah, of course I can. If I can just flag up those people that do use the NCETM, there's some really exciting things coming out before the end of term that I think will really, really help people to pull out the key knowledge and the prior knowledge. So keep your eye out on the NCETM for that resource that's going to come out before, because I think a lot of people are going to use that, found that really, really useful when it comes to next term.
Awesome. There's if you go to my I just want to make sure this was applied because the EIF, the School Inspection Handbook, so for secondary we'll be looking at these things. The school curriculum planning carefully sequences knowledge, so if you're watching some of this and you're not quite, I don't like linking it to Ofsted, but the truth is they're supporting what we're saying as well.
Yeah.
Dividing new material into manageable steps, drawing connections across different ways of looking at mathematical ideas, linking to fluency again, and be able to see it in different ways, opportunities for mathematical reasoning and problem solving, again, to make connections. So the EIF are going to be looking for this, and that's because it makes sense right now. I saw this from Nicola Mary. She's a specialist in London. These microscopic steps, and even look, I just like these questions. They're primary, but they apply all across here. The question that you want them to be able to do in this lesson, what's it mean? What understanding is required to access this? How might it be misunderstood? So these are some of the things we've covered in this hour. Going on to diagnostic question, for example, what understanding is required? Let's make sure that's our AFL. What are the prerequisites? Where are they on the journey? In which order should concepts be introduced? And we'll look at that with the S plan in just a few moments. And then, so there it is. What do I want students to achieve? What steps must I take to get there? What could go wrong? Some lovely questions here. And we're looking at Nicola's blog because I found that really interesting. Now, it says your turn. I'm not going to get you to do this, Helen, so ignore those writing. But imagine breaking down trigonometry in right-angle triangles. And I know you and I both have the same opinion that this is a really strong CPD activity. And I've seen this done, and it comes from Chris Bolton's website. But this, for all of this, for solving, finding a missing angle or a missing side of a right-angle triangle, all of these steps are necessary. And just while clicking through some of these, being able to, changing the order of these would be catastrophic. Number 10, calculate the size of an unknown angle of a right-angle triangle. Well, link that to the points 2 and 3, the skill of using the calculator. You must have those skills ready first. Trying to introduce all the steps of identifying which side, identifying whether it's a calculator, whether it's an angle or not angle, whether it's sine, cosine, all these different things. There's so much going on. And for secondary colleagues, you'll look at this and realize that there is so much in that topic. Going back to this slide here, there it is. Pardon me. We'll go that. What do I want the students to achieve? What steps? What could go wrong? In that topic, there's loads that could go wrong. And so the activity that I think we should talk about, the S planning, is a really good opportunity for teachers to talk to each other, saying, well, what do they need to learn? What are the steps? And the order is really important.
Yeah, I think that the danger is that we've got some great textbooks. Can I just take the screen back again?
Yeah, you should be able to. Let it bounce back and forth. You should be able to.
I think we've got some really great resources. I think the NCETM and the textbooks are absolutely fantastic resources. And there's really good reasoning behind what textbooks do for us. I think if we looked at, what Tim Oates has written about textbooks there, they do really provide that coherence for us, underpinned by, research and lots of experience. And they're fantastic at that. But I think there is a place for working on it yourself. And I think the S planning can come out really, really well. I've done this a few times in CPD, where we've got teachers to really think through a sequence of lessons. Just like, I think when you're planning a literacy unit, you think of the end point and you think of the small steps along the way, don't you? And I think sometimes people do that less in maths. They tend to look at individual lessons a little bit more, or individual objectives. So I think that's really, really important, because you start off teaching children to swim by taking them in at the shallow end and putting their armbands on and everything like that. And you want them to be swimming independently and diving and everything, but you don't just shove them in at the deep end, do you? So it's about getting that sequencing right. And what we've done with S plans is just literally start on huge sugar paper and lots of post-it notes, where teachers are thinking about where are they now, where do they need to be, and what's the journey that's along the way? How am I going to get them there? How am I going to scaffold them? What's the tricky bit? What are the representations? And doing that, I think doing that on your own can be really, really hard, but doing it with colleagues, it can be really, really great CPD. So getting that sequencing right. I've just shoved a couple of examples of S planning there so people can kind of get an idea of what that might look like. And I think what's key when you're creating it is that you can move things around, you can have a discussion, you can suddenly talk to a colleague and think, oh, actually, no, this key step comes in before that. I've done this even with the really great textbook that we're using. I've realised that I've looked at one lesson and another lesson and realised, actually, no, this thing needs to come in between there because our children haven't got that from their prior knowledge. So we need to do a couple of lessons in between. If I hand it back to you, and you've got some S planning to share as well, have you?
Yeah, well, I've got the template that I think is really powerful, and hopefully it's on screen now. And this is the example of the S plan. That's not an S plan. It's a Wavy 2. This is the one that when we started the journey with teaching mastery, they gave us this, and everyone immediately, you can hear everyone muttering in the room. It's nothing like an S. No, just everyone sulking about it. But what I like about the key learning points, it's a reminder of the things. And again, the 5 big ideas last week, we kept getting more links last week. So they're not just in isolation; they all come together. And this idea of coherence, we think about the standard and the non-standard examples that we must use each time. What's going to be our difficulty point, the misconceptions, then the next key learning point, and notice where it is on the journey. And if you have this as I think what would be really nice one day, if I somehow was to make this onto, someone would have made it, where you can move them on a computer and say, well, actually, I'm going to move key point 4 before key point 3 for a reason. And of course, the questions here, and I saw them on one of your examples just then, Helen, these reminder, what representations are we going to use? What mathematical thinking? How are we going to go deeper each time? When you're doing the standard and the non-standard, the conceptual variation, are there multiple solutions that we could use to make sure there's kind of problem-solving activities? But that as a sheet is a good starting point. Always remembering that standard and non-standard. I wish I had better examples, be able to share like you've just shared there, Helen, because all the ones I've got are I'm going to use the word incoherence because I can't read what they're saying. It's not well scanned, so I need to get those done again. It's an activity, as you say, can be very challenging. And I think it'll put staff off sometimes. But actually, as long as they are spending that time thinking about why are we teaching that step, then it's going to pay off. And I think the first time of that activity with a group of people, I've never seen it work straight away. Not to where they think it's worked, but it has worked. Does that make sense?
Yeah, I think it's not so much about the end product, although the end product is really important. It's the learning that takes place between the colleagues as they're working together and they're having those discussions. It's a really great learning activity to actually think about that sequencing rather than just picking up something that's already done. I know the colleagues that are from the NCETM have been working on the lessons, the video lessons for home learning at the moment. And those are great. They've got great sequences of lessons. I'm just gonna grab the screen back.
It's all yours.
Just to show you that very, very quickly, that if you look at those lessons, can you see those?
Yeah.
It shows a sequence of lessons. And I think if you're not sure what a sequence of lessons should look like or how to break down the learning, another thing that I've done with some colleagues is we've looked at the different video lessons that are available on the ones that are recommended at the moment and freely available. And we've compared the NCETM ones to some of the others that are available. And we've talked about the coherence between them and how the baby steps and how some of them maybe take really huge steps and that maybe you could leave some children behind. So starting with those really, really simple steps, but building up. Now, the teachers that put these together said it was really, really interesting. They based this on the NCETM PD materials, but actually they adapted them. They had lots of conversations. They tweaked bits, they changed bits, they added bits, they broke bits down so that they got the sequencing from, this is where the fractions started, where they just looked at what is a whole and what is a part. Before they even went into, I think there were 3 lessons before they went into equal parts. Quite a few lessons before they introduced fraction. But in the end, in Key Stage 2, they got to, where they needed to get to with the complex lessons. But it's that journey going all the way through the school from that early introduction to where they need to get to in Key Stage 2 that's important. So you don't get to children doing SATs where they get to something like that and their brain melts because they haven't got a clue. But I think it's important, I'll just come out to that again, that you don't think you can just pick up a resource and run with it. It's that learning, that coming together to think about why is that resource doing it that way? Why is that sequencing like that? How is that going to work for these children? What have these children done before?
I'm going to go back to, just because you showed dividing fractions, actually, just because I know it happened to be on my screen, so I'm just going to grab this. This was something I saw, again, from the NCETM, and I know it's from a research paper, that the analysis of a series of 4 lessons. Now, I don't think this is just the 4 steps on the lesson plan. I would, as you almost suggested as well, is that lesson design and the curriculum design, the lesson design, what would the steps be involved here, and what representations we use for each of these, and could we break them down even further? But instead of going straight to fraction divided by a fraction and just doing the KFC, a fraction divided by a whole number divided by a fraction, and be able to make those connections. And then you've got a fraction divided by a fraction. Look at these steps here that I want to see. The point of the lesson. Now, the word lesson doesn't mean 60 minutes. So I often try and use the word period, because maybe what I'm going to try to achieve in today's period, there might be a couple of lessons in this period. But the point of the lesson is P over Q is the same as P divided by Q. I remember teaching a year 9 class who could not, they hadn't made that link ever. And it's such a shame. The point of this lesson was to find equivalent fractions and then to simplify fractions and then to compare them, add and subtract, mix numbers to improper multiplying, and only then show the reciprocal, and then dividing fractions. And they thought that would be a good way of getting there. And if you struggle to maybe create those yourself, maybe that's, again, use the NCETM materials. That would be kind of strong advice from us, I would have thought, as to it being broken down. If you've got a good scheme of work, that does that for you. If you don't have that scheme of work, and I still visit schools who just say this week or next week they're doing fractions, and it says add, subtract, divide. I'm thinking, if you've got a non-specialist, or if you've got somebody who's just not confident, that's the work you can be doing with your heads of department and heads maths. So really supporting your staff, which is why you invest in good schemes of work if they exist.
And I think with the two primary textbooks that are on the DFE recommended list, every chapter begins with where they were the previous year. So I think, again, a lot of people worrying about the autumn. Well, actually, you haven't got to panic, because every one of those chapters start from where they were last year. So you can assess that, and you can get the children feeling familiar, and then you can build from there. I think that's really important, as well as pulling out the key learning that they need for the next year and connecting it. Still getting the sequencing right and not rushing through things is really important. Those small steps are still important.
And you said the word small steps. It's a reminder, because I wanted to make sure we did revisit these at the end. The big idea is coherence, of course. We've got one more to go next week, but everything's all linked. But the key message is, with coherence, those small steps are easier to take. They're easier for the pupil to handle. They're all easier for us as teachers to go in depth. They are easier to take. Focusing on that one key point each lesson, remember it says lesson, not period, allows for that deep and sustainable learning. It means you're not shoving the pupil onto another topic. Everyone is learning the same topic in the room. Everyone is doing the same key learning point. Some pupils might be still struggling just with the procedure, with the fluency. Some pupils are trying problem solving, but allows that deep and sustainable learning, those opportunities for deep and sustainable learning, by making sure everyone stays on that one key point. Again, we talked about prerequisites and the pre-concepts that are precursors to later ideas. And that's horizon knowledge, as you described, and it's a lovely choice of word, of where they've got to and where they're going as well. Getting the sequencing is really right. It's an important skill, but getting that knowledge, it's out there. It's on the NCETM. It has that grid to show what they've learned before. So therefore, what should they know? Let's find out. Are they comfortable with it? Let's use it. Let's apply it. And that's the point of part 4 here. Let's make connections with earlier ones that have already been understood. And now it's been deeply understood. It should therefore be used going forward as well. Do you know what? I did say at the start I was a little bit anxious about today. And I think it's just because coherence was always the one I felt least confident with. But even in that hour, I feel a lot more confident. And even that, even saying stuff I already thought I knew, it's talking about it. And what you said about talking with staff, because I could have done this series just by myself, it would be nowhere near as good, because the conversation between you and I, Helen, has helped me. Hoping it's people who've watched, help people who've watched it as well. But I think that's an example, genuinely, of it's okay to work with your staff and ask each other. I know in secondary, staff are a little bit more concerned about it, because they don't think they should be asking each other, because we should already be great at this. It's professional development. We're professionals who should work together. And I think this is a really good activity. Those S plans would be brilliant activities for deepening your knowledge of how pupils learn maths.
Absolutely. Talk together and share ideas together. It gets you thinking.
Indeed, it does. Ellen, thank you for getting involved with these. It's been great fun.
It really has. I've enjoyed it.
I return next week with Faye, the final one, representation, the one that got me into the 5-bag ideas, the bar models. I mean, look behind you. I have a rubbish shed. You have the tens frames and the counters and the dominoes. That's what we're doing next week. But thank you, Helen. I really appreciate your time.